But
Jeremy, what about you? Do you agree or disagree that PID tuning is not a factor? Or just basically, I don't know. Do you agree or disagree?
Oh, it's a big factor. On mine, I can't run the default PIDs. Not with this weird heavy thing that I'm flying. I actually found out that through trial and error, I got my ship more stable, and I ended up sitting around like 105 or 106 on pitch and roll in order to get them to be to be more stable while I'm flying it. And it's really stable up until about 110 miles an hour, and that's when the aerodynamics comes into play and starts causing issues.
See, but I think once you have a stable ship, I think you'll be fine.
Once you get the aerodynamics sorted out, the PIDs won't have to do as much work.
Well, yeah, and back on the motor size thing, one of the reasons I went with these taller motors is the trying to think of how I want to say this because I'm brain farting at the moment.
It's okay.
So as you're fighting the aerodynamics, you can measure the amount of RPM using the modern BL Heli 32 ESCs,
right?
And you can calculate, roughly what the KV should be based off of the voltage. So if you look back through your log files and you log motor RPM and you're logging the voltage, you can take that voltage times the KV of the motor, and that'll give you where the motor would be if it wasn't under load. And then you can take a look at what RPM you're at, and then you can divide the motor RPM you're at by where it would be, and that will give you how much you can kind of figure out roughly where you're at. Like I know on my ship when I'm at about 31,000 RPM, I'm sent at 80% of the unloaded KV.
So this is really interesting. Let's back this up for a second for people who may not have caught what you just said. What a lot of people probably know, but just in case, is that KV is the RPM of the motor times the volts applied to the motor equals the RPM that the motor will make when it is not at all loaded down by like friction, or more in real life, a prop loads it down. So if you are using BL Heli ESC telemetry, you can see the ESCs will report the voltage that they're seeing, and they'll report the RPM that they're making. If you take the voltage times the KV, you'll get the unloaded RPM. Then you can take the actual RPM as a percent of that, and you'll know how loaded the motor is. That's really interesting. So I guess the takeaway from this might be, for those of us who aren't doing top speed runs, that if we want faster quads, aerodynamics is definitely the place to focus. I mean, nobody looks at a typical freestyle quad for sure. I mean, they're horribly unaerodynamic, but top speed really isn't their goal. Whereas the race quads, they've got very thin arms, maybe vertical stacks, trying to minimize that cross-sectional area and make the most of that. What else could we be doing to go faster? What lessons can we take from your top speed runs?
Yeah, for a race quad?
Yeah.
Improving aero on the arms.
But I was going to say something about that. One of the guys that really likes my frame for racing, he said it was too aerodynamic. He said it just, and Kebab FPV, he said
Bob Rugi,
when he went around corners, when he stopped, it just kept going. It would not stop.
Right. It didn't corner.
Normal. So the other guy that I was talking about, he ended up mounting his battery, in a normal horizontal position, because I've also got it where you can do it vertically. So and that helped him a lot.
This is interesting. This is what I was thinking. I actually didn't think you were going to say racers would want this, but I thought, freestyle pilots, we've evolved to expect certain handling characteristics from our quads, and the aerodynamic characteristics are part of that. And we might not like a faster, more efficient, more aerodynamic quad because it wouldn't do things like. But you're also saying that the racers seem to feel the same way too. We don't have brakes. We can't hit the brakes to go around a corner. So if we want to decelerate, we need a certain amount of drag. And the more drag we have, the more the quad can decelerate. But also the slower it's going to accelerate. Unlike a car, when you get off the brakes, the wheels just go, okay. But a quad, that drag is always there, and I guess we need to balance it out.
Yeah, well, he said that it still accelerates like a bat out of hell because, your props are a lot more open.
Mm-hmm.
But, I'm also wondering, I'm not real good with electronics, but
yeah,
sort of like regenerative braking in ESCs, something like that.
Or what if you had, this is a racer will never do this because it's so complicated it'll break, but what if you had a drag panel, and then as you get on the throttle, it opens up, closes and opens up, closes and opens up, so that as you drop the throttle, whenever the throttle's below a certain position, right? Mm-hmm. Or whenever the throttle is moving downward, it closes. And whenever the throttle goes upward, it opens. Oh, I don't know.
Oh, yeah. I've been thinking of things like that.
Jeremy, you said aero on the arms. Go ahead. Tell us more about that.
Well, just aero in general, but on your arms, they're usually a large flat surface. Well, I mean, most of the quad is a large flat surface. And also when it's flying like this, I mean, the air coming in is going to go up and down, and it's going to want to have a downward trajectory to it.
Yep.
So the more you have like that, the quicker, the more drag it's going to have. It's going to want to drive it down and slow it, because I'm sure, as we've all noticed flying freestyle or race quads, when you let off, they tend to want to drop down if you're still at an angle.
Sure. I remember a thing that Andy Shen did, studying the aerodynamic effect of the shape of different quadcopter arms. And he did this, he was mostly looking at the effect of prop wash on the arm. It was a static test on a thrust stand.
Yeah.
And he tried all kinds of different profiles for the arm, airfoil, etc. And what he concluded in the end was that just the smallest cross-sectional area was what made the biggest difference. Aerodynamics, of course, matters a lot more when you're going 150 miles an hour than when you're going 70. I wonder how much benefit if guys like put little trailing fins on them to smooth the to get more, I don't know, laminar flow or whatever I don't know. With that, I wonder how much benefit that might have at 70 miles an hour. Or, gosh, how often do race quads even go 70? Oftentimes they're going slower than that.
Mm-hmm.
Well, okay. There's one more thing I want to talk about before we close up, and that is you're using GPS for your speed runs, and using GPS can report velocity. A lot of people are going to be skeptical of that. They're going to say you should be using radar guns, and they're going to say GPS is only accurate at best to, what is it, like 2.5 meters? Roughly, something like that?
Yeah, for positional accuracy, yeah.
So how can you get an accurate speed run if it's only accurate down to 2.5 meters?
See, that's where the misconception is. It doesn't calculate speed by, how long it takes to get from this point to that point. It calculates it through Doppler, which is identical to the way that a radar gun does it.
Oh.
Now a radar gun is dependent on the angle at which you are to the trajectory of the object.
Correct.
In all dimensions or whatever. And I guess it can be thrown off by reflections and this and that. That's what Guinness actually told me. And also, you have multiple satellites, getting your Doppler, instead of one radar gun.
So people think that the way that GPS calculates velocity is saying, I'm at point A, and then 1 second later I'm at point B, and I'm just going to, subtract the distance out and convert it into a velocity. But if there's 2.5 meters or more of difference, then that's not a very accurate way of doing it. That's a correct conclusion. But what they're actually doing is they're doing Doppler measurements. They're measuring frequency changes from the satellite. And that's actually how they calculate position, isn't it? By doing Doppler calculations. Is that right? Or do they calculate the difference in the arrival times? Ooh, now we're talking about GPS.
Gosh, I don't even know.
But the bottom line is they can do the Doppler calculation on these signals from the satellite and the same way that a radar gun would, but they're doing it on 8 to 12 different satellites. It's way more accurate. How accurate is it? What's the precision?
How accurate? Gosh, I used to know this right off the top of my head. I think it's within 5 centimeters a second.
Yeah,
something crazy.
That sounds about right. It's single digit decimal. That's like 0.1 to 0.05, I think, meters per second. It's really accurate.
Hook it up to beta flight. You take your quad and you just go like this. And you see it.
Yeah. Whereas a radar gun, like the number one source of inaccuracy for a radar gun is that it's aimed up at the quad and the quad is moving toward it, right? So you're only getting this one component of the horizontal velocity. The only way to get a perfectly accurate radar gun reading is to fly straight at the radar gun. Any off angle subtracts from that measured velocity, and never mind, just getting it aimed right and getting a good reading, a clean reading GPS is really the way to do speed runs.
So now if you think about it, then with the radar gun, you're always measuring a slower speed.
Correct.
It won't be a whole lot slower, depending. I think 10-degree angle is what they recommend at the maximum.
And I don't know about you, but I've done speed runs with a radar gun, and I don't like being the guy standing there holding a radar gun while a guy pegs a quad at your face. And he's like, he wants to get the best reading possible, so he's going to cut it as close as he can. And you're like,
UAV Futures style.
What does he do?
On UAV Futures, he has one of the guys go out in the field with a shield.
Yeah.
And then after all the runs, they always attack the guy with the shield.
Yep. Hide behind this car. Oh, that's not better. Yeah. So if you're out there and you're wanting to do speed runs, get a GPS unit. You can get them for about $20 or less. A cheap little GPS unit. Betaflight. You don't need iNav or anything fancy. It's about 1.5 centimeters square. It's tiny. It weighs like 7 grams. You can put it on any Betaflight flight controller that has a spare UART, and you can instantly put a speed reading in your OSD. You can also do direction home and basic, even GPS rescue, basic return to home. But if all you want is speed runs, stick a GPS on it. What are you saying, Ryan?
And it's easy, really easy.
It is. Mostly, I have a video about it. I'll put it down in the video description. So then let me ask you guys, we've ranged far and wide. What else could go into this interview that we haven't talked about that people would be fascinated to know about your experiences in doing these top speed runs?
Well, I'd say, another reason I like to do it is because it ends up, I find different ways of doing things because I'm so restricted in space and this and that, and carry it over to, my next production frame. There's that, and it's just neat to see what happens. And that's part of the reason I didn't go with Jeremy's larger motors, because it's nice to have 2 different paths, because there's more of a chance that something bigger, better is going to be found out.
Yeah.
A lot of this is just experimentation. I mean, it's not like we're in a competition. We're just doing this mainly for fun. I mean, this is
right.
This is how I kill my spare time. It's one of my nerdy hobbies.
And I will say, I'm really glad, especially like Jeremy, as much as I like your massive maotors, I'm really impressed, Ryan, that you're doing these huge speed runs on relatively mundane equipment. And it means that it's more accessible. If somebody out there has a 3D printer and a set of Cobra motors, it doesn't take amazing, like if somebody's thinking about getting an X class and they need $100 ESCs and $150 motors and 12S batteries, you could theoretically, you right out there watching this video, you could theoretically do a 190 mile an hour top speed run with a $25 motor and a $15 ESC and Ryan's frame and some magic in the 3D printer. Okay, it's not quite that easy.
Actually, Ryan's frame without 3D printed, it's fast.
Yeah.
What did yours go without the anything done to it? Didn't it go like 180 or something like that on 6S with nothing, no mods?
Not even a canopy. Really? No.
Yeah, that was yeah, I don't know if you guys heard it, caught it earlier, but yeah, that's what, yeah, this one.
That did
180.
Hey, I just thought of something that we have to get in the interview, because this is actually okay, it's not real common, but it does come up. Motors underneath the arms versus motors on top of the arms. What's the difference?
I have not tried this yet.
Oh, screw you. Oh, I was hoping. I was hoping.
I mean, when I went that, did the 180, 203, I had these flipped up the other way. I do want to try this, though.
Because the argument is that the high pressure air coming off the motor is more disturbed by a blockage than the lower pressure air coming into the top of the prop, and that having the motors under the arms is more efficient. Although, when you have this, we have like 2 millimeters of cross-sectional area, maybe it matters more for like a quad with an 8 millimeter wide arm than a quad like this. Mm-hmm. I don't know.
I was on a pusher setup, but I've converted to a puller now, and the main reason for that is adjusting the center of gravity.
Interesting.
Because it was too far back, and the center of gravity needs to be in front of what's called the center of pressure in order to get it to be stable. So having the motors rear facing actually should be more aerodynamic, because you can put a cone on the back end of the motor.
Yeah.
Yeah, like that.
Oh, interesting. Mm-hmm. Because in aerodynamics, having a big flat front area is bad, but it's actually the vortices in the negative pressure behind that create the drag, and having a tapered rear is more aerodynamic. You're the aerodynamics engineer. You know this, of course, right? Is that right? So being able to put a cone on the back of the motor significantly increases more than if you had a cone on the front of the motor.
Are you talking with having props backwards, the rear-facing props?
Exactly.
Yeah, having a cone, like Ryan just showed, where it's
Ryan, you got it right
into
there.
the airstream.
Yeah.
Mm-hmm. You want to show that, Ryan? Show that cone again?
Yep. Yeah, and then we're also looking to get bigger spinners, too.
I never would have thought. But they have to be balanced.
Yeah, that's one of the problems.
That's really something. That's really something. You're gonna, guys. The right company could make you a custom bell, specifically for your runs. A custom aerodynamic bell.
Mm-hmm.
I was actually going to try 3D printing a cone, since I'm now in a tractor setup. So in a traditional puller, one of the issues with 3D printing, though, is you can get those nose cones to explode if you make them out of PLA. So I tried using more structural materials to do it, like carbon fiber nylon. I've had good luck with that. I've done tube frames with it, and now the carbon fiber tubes are the weakest part of, not the 3D printed parts. So I wanted to experiment with that and see if I can get the nose cones to stay together on those high forces.
Mm-hmm.
Crazy.
Yeah, or I was thinking of like a aluminum core, and then the rest of it with printed material.
That's great.
We'll figure something out.
Yeah. Jeremy and Ryan, I think we're gonna wrap up here. Thank you guys for coming. It's been great talking to you. I'm gonna get a bunch of video and pictures from you guys of and we'll put it in an interview at appropriate places so people can see this is what kind of madness we're talking about here. Anything you guys want to, Ryan, do you want to, your V2 of your frame is coming soon? Is it out yet? Or is it indefinite delay?
Well, yeah, I'm taking my time with it. I want to make sure everything's perfect.
Okay. Well, when it does come out,
issue that I got to make sure is done.
Okay. Let me know when it comes out, and I'll make sure I can mention it just so people can buy it if they're interested. And Jeremy, anything you want to plug? I don't know. Your social media?
I'm not selling anything. This is just what I do for fun.
Cool. Thank you guys so much. I'm Joshua Bardwell, and happy flying. That's the end of the interview. All right.